Hello everyone, in this video we're going to be demonstrating exception handling as a form of error handling in Java programs, and in particular the advantage that this approach has over other error handling methods. So in this video what we're going to do is start with some base code that doesn't have any error handling at all, and then demonstrate how to modify that code using exceptions to handle the errors. And we're going to illustrate the advantage of using exceptions over other forms of error handling. So let's get started right now. In Eclipse, I've created a new project called Exceptions and a new class called Quotient, and we're going to start off with some base code that's going to be what we work from. So what this piece of code does is we create a scanner object reading from the keyboard, and we ask the user to enter two integers. And then we print out the result of number 1 divided by number 2. And let's just demonstrate this to show that it works. Enter two integers, I don't know, 10 and 5. 10 divided by 5 is 2. So this is working. And at the moment that's okay. However, what happens if I do something like this? Enter two integers, 10 and 0. Exception in thread main, blah blah blah, java.lang arithmetic exception divide by 0. So our program crashed because we tried to divide by 0, which doesn't make sense. We can't divide a number by 0. Now, the problem here is that throwing an exception like this is not very good for the end user. The end user should never see a big long stack trace with an exception message. It's much more robust if we write the program to handle this exception so that it never happens, or if it does happen, we have some error handling in there to deal with it. So, how might we modify our code to deal with this possibility? Well, really all we care about is if whether number 2 is going to be 0, right? That makes sense. As long as number 2 isn't 0, then we won't have a problem. So I guess one way of handling this error would be to have an if statement. So if number 2 does not equal 0, then we do the division. Otherwise we print out an error. Right? So at this point, we can run this again. If I enter 10 and 0, divisor cannot be 0. So already our program's much more robust. The user never sees this exception being thrown and our program crashing because we're predicting what the error is going to be and handling it. So that's one way of doing it. What we want to build up to today is a way of doing this using exceptions. Now, the way exceptions work is, imagine we have some code like number 1 divided by number 2. Oh, my pen stopped working there for a sec. Now, this might throw an exception. We saw it just before because we tried to divide by 0. Now, the way exceptions work is we define a block of code that might throw an error. And the way we do this is with the try keyword. And then we have a block of code. Now, what this is saying is anything inside this block of code might throw an exception, and if it does, then we're going to handle it. Now, the way we handle exceptions is at the end of the try block we have one or more catch statements. So catch, and then the type of exception we want to catch. And then finally we have a block of code, and in here goes our error handling. So that's how we write code to deal with exceptions. We use a try block for any of the code that might throw an error, and then we have catch blocks to catch the exceptions. So let's put this into practice over here. Now, if we're going to do this, we don't need this if block anymore. So I might just get rid of this and this for now. So clearly this is the problem. If number 2 is the problem, then we have an issue. So what we're going to do is put all of this into a try block. So if number 2 equals 0, what we're going to do here is throw an exception if number 2 is equal to 0. So instead of our program crashing with the divide by 0 exception, we're going to throw our own exception with a meaningful message. So the way we throw exceptions in Java is the throw keyword and then a new exception object. So in this case, we're going to use an arithmetic exception. And the constructor to this exception takes a message. So divisor cannot be 0. Okay, and now I'll move this operation up into the try block as well. So what we have here is in our try block, we're testing whether number 2 is 0, and if it is, we're going to throw an exception. And otherwise, we're going to do the division. Now, what we need here is a catch block. So catch. Now, inside the catch block, we have to specify what exception type we're going to catch. And it works on a hierarchical nature. So if we catch exception, this will work. This will also catch the arithmetic exception because arithmetic exception is a type of exception. So what we're going to have in here is we'll move this up. And we'll just change the message a bit. Exception. An integer cannot be divided by 0. Okay, so let's see what happens here. Let's run this again. Now, just to make sure it works still, 10 and 5 is 2. Fantastic. 10 and 0. Exception, an integer cannot be divided by 0. So our program still works, and functionally, it's more or less the same as if we had that if statement from before. So instead now we have a try block for any code that might throw an exception, and in our case, we're checking for the number equals whether the number is equal to 0, and then we're throwing an exception. And then finally, we're catching that as well. So why would we do it like that? I mean, at first glance, this looks more complicated than the if statement version. Now, the reason is that exceptions really come into play, and they're really a lot more useful when we're dealing with methods. So what we're going to do now is modify this piece of code to have a method that throws an exception, and then in our main method, we're going to deal with that. So over here, we're going to have a method called public static returns an int quotient, and the parameters are going to be a number 1, so int number 1 and int number 2. Now what we're going to do in here is move this up. So I'll copy that and paste it. Now this method is going to do the exception handling. So if number 2 is equal to 0, then we're going to throw a new arithmetic exception. Otherwise, we are going to return number 1 divided by number 2. And really, this should be back here. My formatting's become all messed up because I copy and pasted. So here's our method that returns number 1 divided by number 2. However, we're doing a check first to see whether whether number 2 is equal to 0. If it is, this method returns an exception, well, throws an exception. So now down here, we don't need this anymore. All we need is this line here. Actually, we don't even need this. What we're going to do is use the quotient method. Int result equals the quotient of number 1 and number 2. The result of, so number 1 divided by number 2 is, instead of doing the division down here, we're going to use the result from our quotient method. So I can put that in there. And the try and catch stay the same. So now we just have a try block that says, you know, this block of code might cause a exception to be thrown, and if it is, we're going to deal with it. So Quotient, the method, might throw an exception. If it does, we're going to handle it down here. So, and then finally we'll have another print line. So here's what our final code is going to look like. Now you can see here that Quotient is the method that might throw an error. Now if that happens, this line will never be printed, because once an exception is thrown, we jump straight down to the catch blocks without calling any more of this try block. So that's kind of important to remember if you can't work out why certain areas of code won't be executed. So finally, let's just double check that this works. 10 and 0. Exception: an integer cannot be divided by 0. Execution continues. So the reason I put this down here is because after the catch blocks, our program continues executing. So we can have code after the catches as well. But with that, that's pretty much for this video. So quickly to summarize, blocks of code that may cause an exception can be placed in a try block, and that allows us to handle the exceptions through catch blocks. So we have a catch block and specify what type of exception we're going to catch. Now, exceptions are particularly useful in libraries. The library can detect the error and let the caller decide how to handle that, and we saw that here. The Quotient method detected an error and threw an exception, but it didn't do any error handling. It left that to the main method, where we caught it and printed out an error message. So that's where exceptions can be quite useful. It separates the detection of errors from error handling. So that's it for this video. Thanks a lot.